Hello, students, and welcome to your day 2 on factoring. And we're going to continue with some of the strategies on factoring, kind of picking up where we left off yesterday. And the first one I want to go through with you is number 1, the greatest common factor factoring method. It's actually the second example in there. We skipped over that one yesterday. And part of it was because the first GCF question we did, we had to make sure and check on a second method. If we were able to use factoring wise. So if we pull a GCF out in this particular question, we notice how we have 3 x's in the first term, 2 x's in the second term, and only 1 in the last term. That means we can actually physically take only 1 x away from each of these spots, which means we are definitely going to have an x out in front. And if we look at the 3, the 6, and the 18, we have a 3x actually in front. The rest of this information, we're going to have to do the leftovers piece of everything that we talked about yesterday. So you're using essentially the distributive property to fill the rest of this in. So that first term, you have your 3 times what? It's going to get you back to 3. It's just a regular 1. And you have those 2 leftover x's that we still have. And then middle term, you have a 3 times what's going to get you back to the 6, where you get the 2 from. And we still have 1 x that's actually left over in that spot as well. And then at the very end, the last term, 3 times what's going to get you back to the 18. That's where you just have your regular old 6. So we did our first method. We did our GCF. Okay, and now we need to always double check to see if there's a second method. And if you look at what's inside the parentheses, there's 3 terms. Okay, there's just a regular 1 in front of the x squared. So that means that we have to try to unfoil this particular example. So as we do that, we make our x in this case. We have a -6 that we put on top, the last term. We put a -2 in the bottom, in the middle term. And we're trying to find what 2 numbers multiply to -6 on the top and add to a -2 on the bottom. Now the problem with that is, as you're thinking, using your fingers, toes, to try to figure something out, it doesn't work. There are no 2 numbers that can fit both of those scenarios. So while we always have to try another factoring method, you don't always have another factoring method. So actually, the very first step would be our final answer for that second GCF question. So if we go on to the next part of our notes, before we get the other example of unfoiling, I actually want to go through the factor by grouping questions, because the factor by grouping questions are going to be a nice little leeway into the second unfoiling question that we have. So factor by grouping is exactly what it says, exactly what you would think. We're going to group 2 of these terms together. The nice part about this is after we group these first 2 together, we are going to take the GCF of these 2 terms. So as you think, you look at a 2 and an x, and we fill in the leftovers the same way that we just did, and we are going to have a 3x before the minus sign, and we have a 5 after the minus sign. So we grouped the first 2, and now we need to do the same thing with the last 2 terms. So as we're looking through this, you have a 3x and a -5. You may notice that they don't have any x or any numbers together, but what they do have is a 1 that you can pull out. And you bring down the rest of the information, do the leftovers, and you're still at a 3x - 5. Now the key with grouping, if you do it correctly, is that the 2 parentheses you have should be the exact same. And if they are, that is going to be brought down for one of your answers. So half of your answer is the 3x - 5. The other piece of information, the other half of your answer, comes from the parts that are before, the actual GCFs that you took out of each of the parentheses that you grouped. So our other half of our answer is our 2x and then a +1. So the final answer is the combination of those 2 parentheses put together. Now the next one is going to be a very similar example. There's bigger exponents, but there's one really important key as we go through this problem. So as you notice, we group the same way, so nothing changes. You have x to the 5th now, and then 5x to the 3rd. So we can actually take out an x to the 3rd in that case now. Once we do our leftover piece of information, we have an x squared still in that spot, and we just have a +5 as our remaining piece. Now the real key with this one, to make sure your parentheses always match up, when we group the second parenthesis here in the 3rd and 4th terms, this 3 is actually a -3. And we need to pull out a negative number of whatever number we find as the GCF. And in this case, we have a -3 that we're actually taking out. Once we now finish this out, we still have our x squared. We still have now our plus 5. So -3 times a positive 5 equals a negative. And we can make sure our matches, our parentheses are the same, and they sure are. So that means one of our answers is going to be an x squared plus 5. The other answer is going to be our x to the third minus 3. Neither one of these situations fit into another factoring method. The first one cannot be difference of two squares. It's not a subtraction. The second one is not a sum or difference of cubes. In this case, a difference of cubes because the 3 is not a perfect cube. So we have our next answer with grouping. You may say, okay, so grouping makes sense. You know, the process isn't too bad. So if we go back up to the unfoiling example, that's exactly what we have to do inside of this method. So you look at the 4x squared minus 2x minus 12 that we actually have here. And now you have a couple options. You can definitely take a GCF out if you want right away. There is no problem with doing that. So I like to get in that habit. We take our 2 out. I'm left with a 2x squared minus a 1x minus a 6. And now you notice we have a number that's actually in front of this x squared. So this is a little bit different method that we have to do. Notice how it's still 3 terms, so we're still going to make our x, just like we did on the other unfolding example. But what we have to do to find this top number is actually multiply the first and the last term together. So instead of just a -6, this is going to be a 2 times a -6, or a -12. And then the middle number will stay exactly the same. Nothing changes with that whatsoever. So as you look at that piece of information now, the nice part is hopefully you figure out what two numbers can multiply to the -12 and add to the -1. You're going to have a -3 and a positive, sorry, -4, excuse me, and a positive 3. So once we fill that piece of it in, this is where that first and last term become really important. Because now after this step, we want to actually make a grouping question. So we're going to make it look like the questions that we just did. So we are going to start with the same first term that the original problem, and in the parentheses at least, had, was a 2x squared. Then we're going to take this -4x and write that in our very next spot. We're going to follow that with our positive 3 that we have as our next spot. And you may ask, well, why do those two numbers get put in place of that? Because when you add those two numbers together, they equal the -1x that we actually have in that spot. So those two numbers replace the -1x. And we finish with our last term of a -6. So as we continue to solve it and go through this problem, now we use our grouping method. We group our first two terms together. We pull out a 2x. We're left with just an x minus 2 in that case. We do the same thing by grouping the last two, and we have a plus 3 that we take out, and we have an x minus 2 here. And notice all of this works out perfect because we have an x minus 2 in one of our parentheses. We have a 2x plus 3 in our other parentheses. And the beautiful part is we can't forget the 2 that we pulled out originally from that problem. So we have done what is the part 2 of our unfoiling question. Right? Definitely a little bit lengthier because you have to do the grouping method inside of it, but still nothing too crazy difficult. The last two questions that I have for you today are going to be two methods that aren't used a lot in at least our math class, but will be used in other math classes as we go. And they're the sum or difference of cubes. So they're perfect cubes that you're looking at. So the formulas are on your note sheet. You will not have to memorize these formulas. They are there for you. So on every problem you're trying to figure out, essentially, what the A is that is cubed and what the B is that is actually cubed. So number 6 example is a sum of cubes because you are adding two perfect cubes together. So the very first spot, or the z to the third power, is all going to be your perfect cube. The reason that it's a perfect cube is because you can get that to be equal to just a regular z. That is the perfect cube of a z to the third. The next spot, or the 64, if you look at that perfect cube, if you break that down and try to figure out what number to the third power equals 64, that's where your 4 is going to be what your B spot is actually equal to. And then all you need to do is fill in your A and B into the spots on your formula over here. So the first parenthesis is just going to be Z plus 4. And as you continue with the next parenthesis, it's your Z squared. And then you have to multiply those two pieces together and then add with it your B squared, which in this case is just a regular old 16. So again, you will not have to memorize this formula. You just have to know how to use the formula and plug the numbers in. The last question of the day is going to be very similar with our difference of cubes because we need to figure out what our A and our B are actually equal to. So the perfect cube of y to the third, if you break that up and split that y up evenly between 3 people, every single person is just going to get a regular old y. And then the 125 that you have, don't worry about the negative sign quite as much, but what number cubed would equal 125? That's where you get your regular old 5. And the same process here, you're filling in this information. You have a y minus 5 by looking at your formula to the right. And then as you continue, you have your y squared. And then you're going to add with it that 5y. And then to finish it off, you square the 5. It's equal to 25. And you have just done both the sum and difference of cubes. Again, not a formula we're going to use a lot in Honors Algebra 2. But it's something that I wanted to put on your radar because you definitely will be using that more as you get up into higher level math classes. Okay, now you can attempt your worksheet and try as many questions on there and bring questions back next day in class. Have a good weekend.